So in this video, we're going to learn about phase transformation. So we're going to learn how to find the composition of the first solid form, the second solid form, first liquid form, and the second liquid form. And also, we're going to learn how to find the liquidous temperature, the solidus temperature, the solvus temperature, and the freezing range of an alloy. And the last thing we're going to look at, we're finding the amount, the composition of each phase at a specific temperature. So we are going to use the lead tin alloy. So we are going to consider a lead, that's we're going to consider the lead as 15% tin alloy. So how do you know this? How do we draw it on this diagram? So what we're going to do now is that let's consider something. First, we need to consider the composition. The composition is in tin, and we are asked to find that is 15% tin in lead. So that means that since this is percentage composition of tin, it means this numbers represent the 10. So 20 weight percent represent 20% weight percent of 10, meaning we have 80% of lead here. So 15% can be 75 and 85% of lead, and also 15% of tin. So where are we going to find it? So before we can find the first solid form, we need to draw the 15% tin alloy in lead. And if you can see, this is the 15% drawn. Now, the first solid to form, we trace it using the first liquid form. This is the liquid phase. This is the alpha phase, alpha plus liquid. This is the eutectic isotherm. So actually, this is a eutectic, a type of phase which is a eutectic, right? That's where a liquid changes to two solids, right? So now for us to find the first solid form, we need to identify the first liquid form. This is the liquidus line. So above the liquidus line, we have liquid. So here is the first liquid form. Then we are going to trace it to hit the solidus line, and then we are going to trace it down. And this will give us the composition of the first solid form, and that will be 8 weight percent of 10. That means we're going to find, this is how we find the first solid, or the composition of the first solid form. Yes, so we need to first identify the first liquid form, that's on the liquidus line, and they trace it to the solidus line and back to the composition line, and that will help us find the composition of the first solid form. Now what if they ask you to find the composition of the last liquid form? Now with this line, this is where the last liquid, we need to trace it to the, and also the last solid, so we need to trace it to the solidus, the liquidus line. So with this is the the liquidus, the solidus line at alpha. So we trace it to the what, liquidus line, and we trace it down, and that will give us the last liquid form. We finding the last liquid form. So the first solid was formed here, and the last liquid was formed here, and that is 43 weight percent of what, tin. So this is how we find the first liquid, the first solid. You need to first identify the opposite end. So when you're asked to find the composition of the first solid, we need to find the liquidus line. That's where the first liquid was formed. Then trace it to the solidus line and back to the composition, and that will help us find the composition. So we are moving on to the second question. And with the second question, they're asking us to find the liquidus temperature, the solvus temperature, the solidus temperature, and also the freezing range of the alloy. Now, how do you do it? Then we try to draw our lead 15% of tin. Then what you do now is, from here, you can see that this is the liquidus line, and this is the solidus line, and this become the solvus line. So then you trace it to the corresponding temperature. So here you can know that it's 290 for the liquidus, and the solidus is 235 degrees Celsius. Solvus line, you're going to get 175 centigrade. So for us to find the freezing range, you're going to subtract the the solidus temperature from the liquidus temperature, and that will give you 290 degrees minus 235 centigrade, and that will give you 55 centigrade for us to find the freezing range. So this is how we find the liquidus temperature, the solidus temperature, the solvus temperature, and the freezing range. Just trace it to the corresponding temperatures. But first, you must identify the liquidus line, the solidus line, and the solvus line. With the same lead tin alloy with 15 tin, we are asked to find the amount, the composition of each phase at a specific temperature. So the temperature we're going to use here is 260 centigrade. So then we need to indicate our 15% tin alloy in lead. So this is it. Then we are going to trace the temperature, which is 260 centigrade. And when we do that, 260 this is 250, so 260 is here. Then after doing it, when it hits any phase, now it's going to hit the solidus line and the liquidus line here. Then we're going to trace it to find the composition. So with this, the amount of phase or the number of phases here present is 2. We have the alpha and the liquid phase. So we need to find their composition and also the amount of liquid phase and alpha phase in this region. So what you do now is that you're going to trace. So this is the alpha phase. So for the alpha phase, for you to get the amount, for you to find the composition of the alpha phase, you need to trace it to the composition line. And for you to find the composition of the liquid phase, you need to trace it to the what? The liquid. This is the liquidus. So you trace it to the composition. Therefore, the composition of the alpha will be 12%. That's 12 weight percent of tin. And for the liquid, to be 30 weight percent of tin. Now, after getting this, what to do now is that this represents composition. So for us to find the composition, we have 12% with 12 weight percent of alpha, 12 weight percent of tin for alpha, and 30 weight percent of tin for the liquid. Now, for us to find the amount, what you do now is you're going to use something called the lever rule. What is this lever rule? You're going to look at it. So the lever rule will help us to find the amount of composition in each phase. So we have two phases here. We have the alpha and the liquid phase. How do you find the amount of it? So now we've traced this. So we know the composition of the alpha to be 12 weight percent of tin and the liquid to be 30 weight percent of tin. So what you do now is you're going to use the lever rule. Now we know that this represents 15%. That's 15 weight percent of tin. So this will help us. So this represents the liquid and this is the solid interval. So for us to find the liquid, we try using the opposite end. So finding the liquid, the amount of liquid, we try using the opposite end. That will be 15 minus 12 all over 30 minus 12. Note this. We use the opposite side. So this side, 15 minus 12 all over 30 minus 12, as we did here. And if it's expressed in percentage, then the answer that you get, you multiply it by 100, and you're going to get 16.67%. That's what you're going to get. So with this, that's what you're going to get. So you know that for us to find the liquid, you look at the opposite side. So the liquid, we are going to look at the solid side, which is 50 minus 12 all over the 30 minus 12. The same thing for the solid. You're going to look at the opposite side of the liquid. So that will be 30 minus 15 all over 30 minus 12. And that will give you 83.33%. For us to do this, you can either find one and subtract it from 100%. If you're asking of the fraction, then you're going to leave it in a fraction form. You're not going to multiply it by the percentage. But if you're asked to find the amount, then what you do now is that you're just going to multiply it by the percentage, anyhow you want to do it. So with this, you can subtract 16.67 from 100%, and you're going to get 83.33%. As simple as that. Now, note that when the temperature given to you is in one phase, let's take example. Now, the amount of that phase is 100%. Note that when it's a single phase, the amount of that phase is 100%. For here, for only liquid, the amount of this phase is what? 100%. And the weight composition is, maybe you are finding the weight composition at maybe 60 weight of tin, and maybe let's assume a temperature of 300 degrees, so it will be here, right? That will be this one. It means that here is a single phase, therefore the amount of liquid here is 100%, but the weight percentage will be what? 60 weight percent of what? Tin. So you should know that. Thank you very much for watching this video. I hope you like the video. Kindly subscribe and like for more videos.